All right, this week or today we're going to be discussing angle relationships. In triangles. And moving forward, instead of writing triangles or triangle, you guys are okay with just drawing the triangle, right? And that would be plural. And just the triangle would be triangle. Saves a little bit of time. Triangle sum theorem. States that the interior angles of a triangle sum 180. Sum 180 degrees. So in triangle ABC here, the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. So if one of the angles is, say it's y plus 10, and another angle is y minus 10, and the third angle is y plus 30. And you're asked to solve for y. Don't these three angles added together have to equal 180, don't they? So in this case, the three expressions. So if you combine your like terms, how many y's do you have?
3.
Yeah, you've got 3y. And then what is plus 10 and minus 10?
0.
That's just 0. So 3y plus 30 equals 180. And if you subtracted 30 from each side, 3y would equal 150. And if you divide each side by 3, then y equals 50. And then you can substitute it to find each angle measure, right? So angle A would be 50 plus 10, which is?
60.
Angle B would be? Angle B would be, get it? B would be. And angle C would be equal to 80 degrees. Very well done. Turn the page and look at example 1 up on the top of 232. There is a surveyor application problem that looks, you've got 3 triangles there and they're kind of combined. This angle down here, KMN, is 88 degrees. Angle N is 48 degrees. LJK is 70. JKM is 104. Asked to find the measure of angle NKM. All right, so the first thing I would do would be to identify the angle. M to K, I'm sorry, NKM is this angle right here, isn't it? It's the third angle in this triangle, isn't it? So couldn't you take 180 and subtract 88 and then subtract another 48? What are you left with? What's 180 minus 88 minus 40? 44? Thank you. So 44 degrees. The measure of JLK. The measure of angle JLK. Which is here, isn't it? Now, they're giving you some clues. What do these three have to add up to? 180, right? Because they form a straight line. They're like a linear group. So you could find this angle measure right here by doing 180 minus 104 minus 44. And what is it? This angle is 88. So now you know two angles in a triangle. So JLK would be equal to... Oh, I wanted 108 minus 104 minus 44. What was that equal to? This is 32? Yeah. Okay. So then this top angle, L, is 180 minus 70 minus 32. Because this angle is 32. Is what, 88? Yeah. Thank you. 88 degrees. 88 degrees. 180 minus 104 minus 44. Because these three form a line, don't they? So they have to add up to 180. That linear pair or linear group of angles is going to show up all year. Please get familiar with it. You have to see this. You have to start seeing this straight line. Okay, straight line. And then in that straight line, you've got this angle. And you've got this angle. And you've got this angle. That combined, they're all touching each other. They all have the same vertex. They all share sides. Okay? Those three added together equal 180. Okay? Any way of finding this angle right here? Or this angle right here? I don't see any way, do you? You're missing two angles in a triangle. You don't know if they're equal to each other. There's not enough information there. Okay? All right, look at the bottom of 232. Let's define the word corollary. A corollary. Is a theorem whose proof follows directly from another theorem. And corollary 432 says that the acute angles of a right triangle are complementary. And who remembers what complementary means?
90.
Good. They sum 90. The acute angles of a right triangle. Well, which ones are those? They're the ones that aren't a 90, aren't they? Good. In a right triangle, you've got one 90-degree angle, don't you? So if this is triangle ABC, which two are the acute angles?
A and C, right?
Yeah, A and C. So by rule or by corollary, the measure of angle A plus the measure of angle C has to equal 180. No, it doesn't. It's got to equal 90. Knucklehead. 90 degrees. Say it again. No, because the question you just asked was saying that in every right triangle, the acute angles are 45 degrees each. That wouldn't be true, would it? Because they have an infinite number of measures that they can equal. Because if angle A is 1, what's angle C? If this is 2,
88.
if this is 3, and on and on and on, right? And on and on and on and on till if angle A is 1.1. If angle A is 1.11. If angle A is 1.111. The only time that angle A and angle C are 45 degrees is when this is an isosceles right triangle. And if that piece was equal to that piece, then these angles would be equal to each other. But I think we'll probably cover that in the next couple of sections. Now, let's do a few examples here. I don't think you need to do an example of this problem. Well, let's do it anyway. All right. Let's say that the measure of one acute angle of a right triangle is given. Find the other. So if we call this example 1 The measure of one acute angle of a right triangle is given. So let's say that one of the angles is 22.2 degrees. All right, this is one angle in a right triangle, one acute angle. The other angle would be equal to, what would the other angle be equal to? Remember, they're complementary, aren't they? So if they're complementary,
68.8.
right, and how did you find that? Did you do 90 minus 22.2 equals? Since they're complementary, you're going to take 90 and you're going to subtract the given angle, and that's 67.8. If you know two angles are complementary and you're given one of them, you subtract it from 90 to find the other one, agreed? So if this is 18 degrees, what's the other one? 90 minus 18, which is 72 degrees. If one of the angles is 30, what's the other one? 60. Now, do you see the pattern? Isn't it 90 minus the given angle equals the other angle? So what if the given angle is y? What's the other angle? 90 minus y. Very good. And what if the given angle is x plus 7? Yeah, exactly. Just follow the rule. 90 minus x plus 7. Any questions so far? All right, let's cover these. The measure. Of each angle in an equiangular triangle is 60 degrees. In a triangle if all the angles are equal, then all the sides are equal. If all sides are equal, then all angles are equal. That's a lot of information, isn't it? So if a triangle is equilateral, what does that mean? All sides are the same. What's the measure of one of the angles? 60. If a triangle is equiangular, what's the measure of one angle? If a triangle is equiangular and one side is 8, what's the other side? It's 8, isn't it? All right. You'll get pictures throughout the year on your tests and quizzes that will look like there's not enough information on the paper. If you're given this picture, and don't write this down, it'll take longer to write it down than it'll take to do it, and you're given this, and you're asked for the measure of angle A. $60, isn't it? All right, because if all the sides are the same, then all the angles are the same. If all the angles are the same, they have to equal 60 degrees each. So you'll look, sometimes you'll look at the problem and you'll freeze up and say, there's not enough information there. You'll be given this picture. You'll be asked to find the value of x. Aren't all the sides the same? If all the sides are the same, then all the angles are the same. If all the angles are the same, what is each angle equal to? 60. So 3x equals 60. If you divide both sides by 3, then x equals 20. Okay? Is that making sense? In this diagram, what is the length of segment AB? Anybody agree? Why? Why is this 8? The diagram shows that all the angles are equal to each other. So you know by rule that if all the angles are equal to each other, then all the sides are equal to each other. And if you know one side, then you know all the sides. Okay? Very well done. Well done. All right, I'm going to stop right there. I'm not going to cover exterior angles. We will do that on Wednesday.